All right, so we are in section 2, and we're going to still talk about equations, but we're going to focus more in this section on linear equations and rational equations. In the last section, section 1 on Friday, we kind of talked a lot about different types. Like we went over some linear, but then we went into quadratic, the parabola ones, and we also saw an absolute value graph. So we kind of just talked about generalizing how to understand like movement and how to write equations for that. We're going to focus a little bit more today on how to solve equations. So not necessarily graphing, but how do you solve for the variable that's maybe in your equation here. We're going to first start out with linear equations. You guys have probably solved linear equations 100 plus times in the last 4 years, okay? You've done this process that you should hopefully know what to do here. When you have a linear equation, you're just trying to solve for that x. So on this first one, what are you guys going to do first? You're going to subtract 5. So I would rewrite this now as 4x equals 24, and then what? Good, divide by 4, and you get 6. Like I said, you've probably done that a lot. You should be pretty comfortable with how to solve something like that. Now, if we have linear equations that involve fractions, so coming down to this next one, we still have x's involved, but instead of it just being 4x plus 5 equals 29, they're throwing in rational parts. They're giving you fractions now. And we talked about this in the last chapter towards the end when we were kind of simplifying those rational expressions. We worked on factoring and then being able to cross things off. We're going to still kind of use a little bit of that we learned from the first chapter where you have to understand what the least common denominator would be. But the difference is I don't want to have fractions when I try to solve this. I'm trying to get rid of the fractions by using my least common denominator. So I want you to think about the bottom numbers here. We have a 4, a 14, and a 7. Can you guys think of a number that all three of those could possibly go into? 28. So I'm going to write over here that my least common denominator is 28. And then what I'm going to do in order to get rid of my fractions is I'm going to multiply every single fraction by 28. So I'm going to do that to all three here. Now, when I do this, I want to get the bottom of the fraction to simplify a little bit with that 28 before I try to multiply the top. So can 4, or I guess I should say, how many times can 4 go into 28? 7. So I'm going to reduce the 4. I'm just going to cross it off, and I'm going to rewrite this 28 as a 7. And then I'm going to take that 7, and I'm going to multiply into the x minus 3. Make sure you distribute there since they're two terms. So that would become 7x minus 21. Okay, equals. And then see how I got rid of my fraction there? I'm going to continue to do that on the other two now. I'm going to multiply by the 28. I'm going to try to simplify first to get rid of the fraction and then multiply by whatever's left over. How many times can 14 go into 28? 2. So you're going to take 2 times 5, which is 10. And then the last one, how many times can 7 go into 28? 4 times. So you're going to take 4 times x times 5. And there is a subtraction sign here, so I'm going to write minus. And then if I multiply by 4, what do I get? Now, I put that in parentheses after that minus sign because we've seen this before. But when there's that subtraction sign, it goes into both of those terms. So it's going to cause them to switch their signs. So we'll just have to make sure that we keep track of this, that this is going to come in and make that 4 and that 20 become negative. So I'm just going to rewrite that so I don't have parentheses anymore. And I'm switching those signs. Okay, so now we're back to just like a linear equation. There's no more fraction. So this looks like what we just dealt with. There's just a lot of pieces here. So we have to try to get our like terms together. Let's work on the numbers first. I should be able to combine the 10 and this negative 20 over here right away. And then I will have to deal with this negative 21. So you can kind of do that step by step if you want. Some of you can maybe deal with this mentally. Over here on the right side, what would be 10 minus 20? negative 10. So I'm just going to rewrite, I've got negative 4x minus 10. And then what would you need to do? Yeah, add that 21 or the 10. It doesn't really matter to the other side. What I would maybe suggest that you do is add the 21 over. The reason why I say to do it that way is because I see a negative 4x. If I can, I like my x's to be positive. If I keep the negative 4x over there and I move the 7x, that's going to be subtracting a 7x, and that's going to become a negative x. It's not like a wrong way to do that, but if I want to avoid dealing with a negative in front of the x, I'm going to just keep that in mind. So now I have 7x equals negative 4x, and then negative 10 plus 21 would be negative 11. And then what would we do? So we're going to add that 4x over. It would now become positive 11x. Oh, yeah, you are right. It would be positive 11 over here. Thank you. And then equals 11. And so what do you get for x? 1. Questions on that? Okay, so let's do another one similar to this where we have a rational expression. We have to think about the least common denominator. But they'll also start throwing in those variables in our denominator. And so we also have to think about what would cause issues here. Just like when we were working with these rational expressions in the last chapter and we would factor, we would set those little factors equal to 0. And then the numbers that we got when we solved for the x, those were what x couldn't equal, because then it would zero out your denominator. So we still want to be aware of that and make sure that we're writing those out as like, those would be like your restricted values. So for this first one, let's just think about this question. Where's the function undefined? What number would you need to plug in for x to cause the denominators to zero out? Well, 2 times what would be 0? 0, right? Because anything times 0 is 0. So I could put in a 1, a 2, a 3, a 4, a 5. I could put in a negative 1, a negative 2, a negative 3. I could put in really anything but 0. The second I put a 0 in there, it gives me a 0 in my denominator, and I can't have that. The same thing affects the over here where it says 3x. I can't have 0. So I'm going to just write over here, x cannot equal 0. Okay, now what I want you guys to think about is what would be your least common denominator. Well, I don't think 18 can go into 6. So 18. And an x, because I do have an x on some of these. So I'm going to say right here, my LCD is going to be 18 and an x, and I'm going to multiply all parts of my problem by that 18x. Okay, so let's deal with this here. 2x can go into that 18x. How does that simplify? I get rid of the 2x, but what does the 18x become? Just 9, because the x's are gone. 18 divided by 2 would become 9. And then I take 9 times what? 5, which is? 45. Good. Equals, what happens on the second fraction? Does it all go away? The 18 goes away, but the x is still there. So you got to take 17 times the x, which would just be 17x. Okay, minus, what happens on the last set? 6 times that 1. So it's just 6, but there is that minus sign in front of it. Okay, can you guys finish it from there? Take maybe a minute to finish that. So I would have added 6, so I got 51 equals 17. X, when you guys divided by 17, what'd you get? Good, 3. So x equals 3. And if I needed to, I could just say x can't be equal to 0, but we did state that already, so I think that works. Any questions so far, guys? Okay. This next one is similar. They want us to use these two separate equations, and they want us to figure out what value of x would allow these two separate equations to be equivalent or equal to each other. And then we also still need to look for those restricted values. What are things that maybe we can't have x be equal to? So instead of them just like setting up the equation for us, they have them just kind of written out in two different ways. They're saying that y1 is equal to this 1 over x plus 4 plus 1 over x minus 4. And then they're saying y2 is equal to this 22 over x squared minus 16. So they have them separated. What I'm trying to do is like set them equal to each other and figure out what does x need to be in order for that to work out. So if I were to plug in an x value and simplify it, when does that become that they would equal the same thing? So I'm going to just first by start rewriting it so that I'm setting equal y1 and y2. Okay, so I've got them set equal. Think back to the last chapter, we did some factoring. The first equation that they gave me in y1, I don't really need to do any factoring with. But the second one, I should be able to factor that x squared minus 16. How does that factor?
X plus 4, x minus 4.
Good, so I'm just going to write that x plus 4, x minus 4. Okay, that takes care of that. So now think about least common denominator. We want them to have the same pieces. They all need to have an x plus 4 and an x minus 4. Some have one or the other, and the last one has both. But I'm just going to write my LCD here needs to be both pieces. Okay, before we get too far into actually solving here, what can x not equal? I don't think 0. I think 0 would be fine, because if I put 0 in for that first one, it would be 0 plus 4, and that's 4. So, what'd you say? Why?
Because for x plus 4, you can't have a negative 4, because it would be 0.
Uh-huh. So he said positive and negative 4, because if you're putting in negative 4 and you add that to 4, that zeroes out. It's like, think about setting these pieces here equal to 0. What happens? You get the opposite signs. So I'm going to go ahead and write just underneath my LCD for right now, x can't equal positive or negative 4. All right, now let's get to simplifying. So let's multiply everything by our LCD. Okay, so I've got it all written out. On my first fraction, what can we cross off? X plus 4 is good. And so I have x minus 4, and what am I multiplying that times? 1. So it's just going to say x minus 4. That takes care of the first fraction. What crosses off on the second one? Okay, and what am I left with? Again, that's times 1, so it doesn't change at all. What happens on the last set? Everything's gone, and we're left with 22. Okay? What happens next? 4's cancel. And so we have what? 2x equals 22. Divide by 2, and we get what?
11.
Good, 11. Questions on that one? Okay, with these equations, kind of going back to just linear equations here, there's times where you'll have equations that maybe look different at first, but then if you actually start to simplify, you'll recognize that they have some things in common. And then there's like these special cases when you're looking at equations, especially if you were looking at graphing them, like what happens when you graph them as far as their solutions. So we're going to kind of go into that and talk about two different cases. One of them is called the identity case, and that is when your equations that you have are technically the same thing. So sometimes they just appear different because maybe the one is being multiplied by something that you could take out, or there's like common terms that haven't been put together yet. And then when you do all that simplifying, you get equal equations. The other one would be called inconsistent. And this would be that everything looks the same except one little tiny piece causes a little bit of a disruption, and it causes them to not actually be equal to each other anymore. So for example, this first one is an example of an identity case. It says 3 and then in parentheses x plus 2 equals 3x plus 6. Well, if I were to distribute the 3 here, then I get 3x plus 6 equals 3x plus 6. That means that it's equal to itself, so that's always true. So it's called the identity. What this also means is that it has infinite number of solutions. For example, if I wrote that out, that means I could have negative infinity to positive infinity for solutions here. Any number that I put in for x on either side is going to equal itself out. If you think about this on the graph, if I were to graph 3x plus 6, it would look something like that maybe. And the other one would literally be the same line just right on top of it. So if you were to graph both of them, you'd be graphing the same line 2 times. And so they share everything. All their points are going to be the same. Now the second example is inconsistent. So when I look at these kind of separated out, again, they distribute the 4 over here. And so they got 4x minus 4, and then they added that 3 on. But this time when they did that, they had 4 x's, but the left side said -7 and the right side became a -1. The 4 x's will cancel off if I were to combine them, and I'm left with this expression that says -7 equals -1. That's not true, and it will never be true, okay? So this doesn't have a solution. So we would say it's inconsistent, or we would say there's no solution. Okay, or maybe they'll write a 0 with a slash through it, meaning that there's nothing that works. And what happens here is because it had the same x term, that means it has the same slope. So these lines are moving in the same direction and at the same speed on a graph, but they're never going to intersect. What do we call those kind of lines? If they never cross. Parallel. So these would be parallel lines. So all parallel lines are no solution problems because they're never going to cross each other. So what I want you guys to do is there's 2 problems down here. I want you to simplify both of them, and I want you to write out, is it inconsistent or is it identity? There is one of each. Okay, so I kind of worked them out here. That first one that you did, you should have ended up here where it says 6 equals 2, which is not true. So we would call that what? Inconsistent. The other one, when you solve it all out, you get x plus 1 equals x plus 1. And so that would be what case? Good, identity, because they look the same. Good. Okay, we've got one more problem. If you guys flip your page over. All right, so this is just taking what we talked about today, but it's applying it to a formula that maybe is representing something. So this problem says, persons with a low sense of humor have higher levels of depression in response to negative life events than those with a high sense of humor. This can be modeled by this formula. D equals 10 over 9, x plus 53 over 9. In this formula, x represents the intensity of a negative life event, and D is the average level of depression in response to that event. If the low humor group averages a level of depression of 10 in response to a negative life event, what was the intensity? So 10 is the level of depression. So that's going to go in for your letter D for this equation. So I'm going to put 10 in that place, and I'm going to set this up. 10 over 9, x plus 53 over 9. Now 10 right now is not written as a fraction, but think of it as like over 1. I need to get rid of that denominator. So think about when we were doing that at the beginning of class. What would be my LCD here? 9. So I'm going to multiply everything by 9. That'll get these fractions out of here. So on this first one, I'm just going to take 9 times 10 because there's nothing to cross off in the bottom. So that just becomes 90. What happens on the second fraction? Okay, and for the last one? Yeah, equals 53 or plus 53. Okay, and then we just need to solve. So we're going to subtract 53 first. So 90 minus 53 would be 37 equals 10x. If you divide by 10, what do you get? 3.7. So x is equal to 3.7. That would be the intensity of the event. Any questions on that one?